Warning. This podcast contains humans.
Hi, how are you doing? This is Matt, and welcome to another MSPx. Regular listeners to the MSP podcast will know that physics is one of the many areas of science that I struggle with. Often when I read a physics article or paper, I go back and I have to read it over and over again, or at least that's what I tell myself I'm going to do. Often it just gets added to the THCR pile. That's too hard, couldn't read. This time I had one of those real WTF moments and immediately shared the piece with my MSP co-host, Jeff. I've read it over and over since then in the hope that I can try and explain it enough or grasp it enough to explain it to you here. So the next 5 minutes are going to demonstrate how poor my knowledge of physics truly is, but it is one of the most amazing and mind-boggling things I've read in, well, probably forever. So where do we start? I think we start with time. A lot of us have always wanted to go back in time, either back to the future style to check out some moment in the past or to try and alter some of the mistakes we've all made in our own past. But what we know about the properties of time and space, or at least the bits that I'm able to understand, is that it is theoretically possible under some models to travel forward in time, but probably not back. In order to actually go forward in time, it would need so much energy that it would probably shred the molecules in our body. So while the matter that makes us up would complete the journey, we as kind of physical functioning human beings wouldn't. But what if there's a parallel universe where everything is the opposite of our universe and time as we understand it actually runs backwards? Now, it's worth taking a second just to let that sink in. The idea that up is down, left is right, and of course that time runs backwards. To be honest, I still can't get a really good mental grip on this at all. Let's go back to 2016. An Antarctic research station called ANITA, which stands for the Antarctic Impulsive Transient Antenna. This was searching for evidence of high-energy particles from space hitting the snow and ice amongst all the cosmic rays that are constantly bombarding us. What they found was evidence of a particle that seemed to burst from out of the ground. So it was coming from inside the planet rather than from space. Of course, this is pretty much impossible under the standard model of physics because high-energy neutrinos and cosmic rays shouldn't be able to travel all the way through the planet. They should essentially flatten or bounce once they hit the surface. So obviously, a single instance, while that is interesting, you can easily write that off as equipment error, interference, any number of different things. But then it happened again in 2018. So a lot of theories have been developed to explain what this particle might be and how this is actually happening. It could be a hypothetical particle called an axion, or it could actually demonstrate the validity of supersymmetry, the extension to the standard model that holds that every known particle has a twin. But these examples both break that standard model, or at the very least, they extend it in some new ways. According to Neil Turok at the Perimeter Institute for Theoretical Physics in Waterloo in Canada, maybe there is an answer to the exploding neutrino that doesn't break that standard model. It helps to understand this if you know a little bit about CPT symmetry. I'm trying to keep the show short, so I'm not going to go into it here. As a shortcut, we can just go to the moment of the Big Bang, where CPT symmetry, that concept holds that there would be equal amounts of matter and antimatter in the universe. Theoretically, these should destroy each other, which means that our universe shouldn't exist. And that is problematic because unless we are a computer simulation, which some mathematicians do suggest we might be, we do at the very least believe we exist. So scientists like Turok have used the Antarctic findings to support another idea. And that idea is that the Big Bang created two universes. One, which is ours, is almost devoid of antimatter, and another, which consists mostly of antimatter and very little matter. So while our universe moves forwards and expands, and you have to use some mental gymnastics that I really can't quite grasp. In the antimatter universe, that universe would actually be contracting and rushing back in time towards the Big Bang. And if you're still struggling with that, that would only be our perception. In the parallel universe, the one where planets and stars and even living things are made of antimatter, they would perceive us to be the ones contracting and heading back towards the Big Bang. They would perceive our universe as being the one where everything is wrong and back to front. And that also means that time is not the thing we think it is. In reality, time itself may depend on which way your own universe is heading. Now, of course, all of this is just completely nuts. It may turn out to be nothing for the simple reason that you might expect other similar particle explosions to have been detected, but then we haven't been looking for them up until now. So we may have dismissed earlier findings as background noise, or we may have even wrongly categorized those particles. It's possible that the track of these high-energy tau neutrinos could have been mistakenly categorized as muon neutrinos instead. I don't know what any of those things are, but you can look them up. So a lot more research needs to be done, but this is simply an incredible idea. An antimatter Matt making this show on an antimatter Earth that's heading backwards in time. Thanks for watching and listening. I'll be back with another MSPx very soon. You can listen to the weekly show MSP on your favorite podcatcher. For now, stay safe, stay home, unless, of course, you're an antimatter me in another universe, in which case you've already done it.